Hello everybody, so in this video we're going to begin with chapter 2, functions. So these are the learning objectives of the chapter, and by the end of the chapter you should be familiar with different forms of equations, of lines, gradients, intercepts, parallel, and perpendicular lines. The concept of function, which includes domain, range, and graph. Function notation. The concept of a function is a mathematical model. The informal concept of an inverse function as a reflection in y equals x, and then the notation of the inverse function of f. The graph of a function and its key features, including x and y intercepts, vertical and horizontal asymptotes, then using technology to graph a variety of functions, and finally using technology to find the intersection of two curves or lines. So we will be working with section 2.1, equations and formulae. First, we start with equations, identities, and formulae. So in example 2.1, they want us to solve for a variable. So for letter A, they want us to solve for B in the expression a squared plus b squared is equal to c squared. So we want to solve for B. That means that we would have to subtract a squared from both sides, right? Subtract a squared, and we're going to get b squared is equal to c squared minus a squared. Then we can square root both sides, and we're going to get that b is equal to plus minus the square root of c squared minus a squared. Now, if b is, say, a length, if b is a length, then b would have to be positive. So b would be equal to the square root of c squared minus a squared. For b, they ask us to solve for L, and the expression t is equal to 2 pi square root of L over G. So notice that we can rearrange this and switch it around and say that the square root of L over G is equal to t divided by 2 pi. So notice that this is multiplying here, so we can send it to divide t. The next step would be to square both sides. We're going to assume that this is a positive measurement. So let's just say that this is going to be then, or the next step would be that, and I'll continue it here where I still have a little space. If we square both sides, we're going to get that L over G is equal to t squared over 4 pi squared. So notice that I'm squaring this side, and I'm also squaring this side as well. Okay, and the final step, which is to solve for L, will give us that L is equal to t squared times G divided by 4 pi squared. So in letter C, they want us to solve for R in the expression I is equal to n times capital R over capital R plus small cap r. So they want us to solve for capital R. The first step here is to multiply both sides by the expression R plus R, right? Or capital R plus small cap r. So if we do that, we are going to get I times R plus small r is equal to n times capital R. The next step is to distribute this here, meaning I have to multiply this by I as well as this. So I'm going to get Ri plus small cap r times I. And this equals n times capitalized R. So now we have to bring the expressions that have R to the left and move this part to the right. So we're going to get capital R times I minus n times capital R is equal to negative, because it's positive on this side, negative small cap r times I. Then we need to factor out r here. Notice that we can rearrange this expression to the left as r times I minus n is equal to negative small cap r times I. And then finally, we're going to do the last step here. R is going to equal minus small cap r times I over I minus n. And in some textbooks, you might see that they rearrange this in order to get rid of this negative. So how can you do that? Well, you can put a negative in front of this and switch the signs around here on the bottom. So let's do that here. We can rewrite this as minus r times I over minus, notice that I'm switching the order here, n minus I. So this cancels out, and now I have everything in positive terms. So we have that r is going to equal, and we like to arrange things in alphabetical order. So I times small cap r divided by n minus I. So in the next slide, you're going to find a brief explanation on linear equations or equations of lines. Now, there are several ways for writing linear equations. You have the general form, which is this one here, where you have ax plus by plus c equals 0, and you can write it as ax plus by equals c. So what's an example of this? Well, if you have 2x minus 3y plus 2 equals 0, this would be a linear equation. Notice that you can rearrange this and rewrite it as 2x minus 3y is equal to negative 2, which is this second form here. There's also the gradient intercept form, which is this one, y equals mx plus c, where m is the gradient or slope and c is the y-intercept. 0 comma c, I should say, is the y-intercept. So what's an example? Well, for example, if we have y is equal to 2x minus 3, then this here would be the gradient of the function, and this here would be the y-coordinate of the y-intercept. It means it would go through 0 comma negative 3, and it would have a gradient of 2. That means that it looks more or less like this. It would be a positive gradient, and it would go through 0 comma negative 3 in the y-axis. We also have the point gradient form, which is this one over here. And m is the gradient, just like it was in the case before. x1 comma y1 is a known point on the line. So what does that mean? That means that if you know that you have a point, let's say 2 comma 1 on a line, and you know that the gradient of the curve is equal to negative 3, then you can write that equation as y minus 1 is equal to negative 3 times x minus 2. And notice that you can multiply this and expand it and rearrange it in any other form, including the general form or the gradient intercept form. Then we have the last two cases. You have the case where y equals c, where there is no gradient or it's 0, and c is the y-intercept. And then you have the vertical line where you have x equals c with undefined gradient. So what does this mean? Well, if you have an example, y equals 4, then the graph of that would be a horizontal line that goes through y equals 4. So if this is 4 here on the y-axis, this is the y-axis, this is the x-axis. So if you have y equals 4, it would be a horizontal line that goes through the point 0, 4. If you had another line which would be x equals negative 3, that would be a vertical line that goes through the x-axis at x equals negative 3. So if we have negative 3 here, the line x equals negative 3 would be going right through there, and it would have an undefined slope. So next we have example 2.2, and it says, without using a GDC, a graphing display calculator, sketch the line that is the graph of each linear equation written in general form. So these equations are written in general form, and they want us to graph them. So for A, we have 5x plus 3y minus 6 is equal to 0. In these cases, what is recommended is to rearrange this and write it in the gradient intercept form. Remember that the gradient intercept form is y equals mx plus b, for instance. So we can rearrange this and write it as 3y is equal to negative 5x plus 6. Don't forget to change the signs on these when you move them to the other side of the equality. And then we can divide both sides by 3, and we're going to get y is equal to minus 5/3 x plus 2. So notice that I'm dividing here by 3, and I'm dividing all of this by 3 as well. And what we have to do now is graph it. Good thing is that we already have a y-intercept. The y-intercept is 0, 2. So that means that the graph will go through the point 0, 2. That's one thing. So remember, this is the y-axis and this is the x-axis. So now what we can find is an x-intercept, for example. So how do we find an x-intercept? Well, this has a negative slope, so it means that it will be going downward. It should go down in this direction. But let's find the exact x-intercept in order to do an accurate graph. So notice that at the x-intercept, y is equal to 0. So if I say that 0 is equal to negative 5/3 x plus 2, I can solve this for x and find the x-intercept. So I'm going to get that negative 2 is equal to minus 5/3 times x. Therefore, x is equal to negative 2 times the inverse of this, right? So that would be times 3 over negative 5. And then I'm going to get that x is equal to 6 over 5. And this is equal to 1.2. So that means that the x-intercept is going to be 1.2, comma 0. And that, let's say, would be around here. Therefore, we can draw the graph as follows. So this would be the graph of the linear function for part A. For B, they have y minus 4 is equal to 0. So notice that we can simply rearrange this as y equals 4, and that's easy. This is just a horizontal line that goes through y equals 4. So let's say this is 4, and this would be the graph of y equals 4. For C, they give us x plus 3 is equal to 0. Rearrange this, it's going to be x equals minus 3, and this is just going to be a vertical line. So then the graph of that is simply going to be a vertical line that goes through x equals negative 3, and this would be the graph for C. Very well, so now we are on example 2.3, and part A says, find the equation of the line that passes through the point 3, 31 and has a gradient of 12. Write the equation in the gradient intercept form. So the gradient intercept form, recall that is y is equal to mx plus b or plus c. But we're not going to use this form directly. We're rather going to use the gradient and point form. What is the gradient point form? Remember that the gradient point form is y minus y1 is equal to m times x minus x1. And for this, we need the gradient and we need a point, which we already have. Notice that we have the point 3, 31. So this is going to be x1, and the 31 is going to be y1. So this will be y1. And then m is the gradient, which we know from the problem is 12. So now all we have to do is substitute. So we're going to get y minus 31 is equal to 12 times x minus 3. Okay, but we're not done because they want us to write the equation in the gradient intercept form, which is this form here. So that means that we have to rearrange this for y. So notice that we can say that this is the same as y is equal to 12 times x minus 3 plus 31. And then y is equal to 12 times x would be 12x minus 12 times 3, which will be negative 36, in this case, minus 36, and then this plus 31. So notice that we're going to get that y is equal to 12x minus 5. So now we are on part B of example 2.3, and it says find the linear equation in C and F, knowing that when C is equal to 10, F is equal to 50. And when C is equal to 100, F is equal to 212. Solve for F in terms of C. So they want us to find the linear equation, and now they're not talking about X and Y, but it's exactly the same thing. Notice that these coordinates they're talking about are going to be 10, 50, right? Because when C is 10, F is 50. And then we also have that when C is 100, F is 212. So recall that when we want to write a linear equation, we need y minus y1 is equal to m times x minus x1. Or in this case, because they want it in terms of f, we can say f minus f1 is equal to m times c minus c1. Okay, so we already have a point, right? We can take this point to substitute for C1, F1, right? This would be C1, and this would be F1. So we have what we need to plug in, except for the slope or the gradient. But in general, we know that if we have 2 points from a line, let's call those points in general, right? X1, Y1, and X2, Y2. We know that if we have those 2 points, the slope is going to equal, some people like to call it rise over run, which is the same as saying difference in y over difference in x. And this is the same as saying y2 minus y1 over x2 minus x1. The important thing here is to maintain the order. Notice that if we start with y2, we have to start below with x2. Okay, so now we can find the gradient of this equation by applying this formula. So what are our x1 and y1? Well, this is in terms of C. So we have C1 and F1, and let's say C2 and F2. So instead of y, remember that we have F, so we can say simply that this would be F, F, and C, C. So notice that it's just F2 minus F1, because that's the equivalent of the y coordinate, over C2 minus C1, which is the equivalent of the x coordinate. So this is going to be 212 minus 50, the difference in y, or the difference in f, over the difference in c, which is going to be 100 minus 10. Notice that we do it in the same order, starting with C2 and F2. And in the end, you're going to get that this is equal to 9 over 5. So now we have all the information we need. So we said that m, or the gradient, is equal to 9/5, or 9 over 5. So now we can substitute, right? So it's going to be f minus f1, which we said will be 50. But you can also do it with these coordinates, and you would get the same answer, by the way. So f minus 50 is equal to 9/5 times c minus C1, which is 10. And then all we have to do now is solve for F, right? Because they want us to solve for F in terms of C, as it says right here in the problem. Solve for F in terms of C. So then we can say that this is the same as F is equal to 9/5 times C minus 10 plus 50, right? Because I'm moving 50 to the right-hand side, or this negative 50 to the right-hand side, so it's going to be plus 50. So then we have that F is equal to 9/5 C minus 18 plus 50. And this is finally going to equal to F equals 9/5 C plus 32. So in the next slide, you're going to find a couple of lines on the left. In this graph, these lines are parallel. So if you have two lines for which the gradients are equal, then the lines are parallel. So what does that mean? Well, if you have a line, for instance, y is equal to 0.25x plus 3, and then you have another line that is y is equal to 0.25x plus 1, then these two lines are parallel because they have the same gradient of 0.25. So these would be parallel. Then we have lines that are perpendicular. So when do we know when lines are perpendicular? Well, if their slopes multiplied give you -1. For instance, if you multiply -4 times 0.25, which is the same as 1/4, if you multiply this by 1/4, this is going to equal -1. Another way of looking at it is if the gradients are opposite in sign and also multiplicative inverses of each other, like in this case where you have -4 and the other gradient is 1/4. So notice that we could have a line, for instance, such as y is equal to -4 x minus 17, and then another line which could be y is equal to 0.25 or 1/4 x plus 1. So these two lines would be perpendicular because, again, if you multiply their slopes or their gradients, you will get -1. So next we're going to do example 2.4, and it says consider the straight line with equation y equals 3/5 x plus 2. So notice that this is in the form y equals mx plus b, also known as the gradient intercept form. So for A, they want us to find the gradient and the y-intercept. But because the equation is already in this form, that's easy to solve because we know that the gradient is equal to 3/5 and the y-intercept is going to be 0, 2. For part B, they want us to find the equation of a line that passes through the point 1, 5 and is parallel to the given line. Because it's parallel, it has to have the same slope or the same gradient, right? So m is equal to 3/5. So notice that now it's easy to find the equation because we can use the formula that uses the gradient and a point. So let's just call this here x1, and this we can call y1. So recall that the formula is y minus y1 is equal to m times x minus x1. So all we have to do is substitute in this. So y minus 5 is equal to 3/5 times x minus 1. And then we expand this and solve for y. So y is going to equal 3/5 times x minus 1 plus 5. Again, remember that we have to change the sign here. So y is equal to 3/5 x minus 3/5 plus 5. So we have to do the sum, and then we're going to get that y is equal to 3/5 x. And once we have that, all we need to do is add this and this. But remember that this is the same as saying 5/1, so multiply by 5. And this is going to be 25/5. 25/5, and 25/5 minus 3/5. So 3/5 x plus 22/5. So now we do C, and it says find the equation of the line that passes through the point 1, 5 and is perpendicular to the given line. So we still have the point 1, 5, but it's perpendicular to the given line. So remember that if we have that the slope of the parallel lines is 3/5, then the slope that we need, let's call it m2, is going to be opposite in sign and inverse, so -5/2. over 3. So now we're ready to use the point slope formula, or also known as the gradient point formula. So that's y minus y1 is equal to m times x minus x1. So all we have to do is plug in everything. Y minus 5 is equal to negative 5/3 times x minus 1. Rearrange, so y is equal to minus 5/3 times x minus 1 plus 5. And then we get that y is equal to minus 5/3 x, and then plus 5/3, right? Because negative times negative is positive, so plus 5/3 plus 5. So here we have to add these two, multiply by 3, multiply by 3, and we're going to get 15/3. In other words, y is equal to minus 5/3 x plus 20/3. Very well, so now we are going to do example 2.5, and it says line L is given by the equation 3y plus 2x equals 9, and point P has coordinates 6, negative 5. Part A, explain why point P is not on line L. So they're telling us that point P is not on line L, and we have to show why. So one thing about lines is that every set of points that is on the line has to be a solution to this equation. What does that mean graphically? Well, if you have the graph of, say, this line, let's suppose it goes like this, then all the points that are on the line, every single point, every single coordinate here on the line would make this equation true. So if 6, negative 5 is not on the line, it could be somewhere around here, let's suppose. Okay, so how can we prove that? Well, let's just substitute for x and y in this equation. So we would say 3 times negative 5 plus 2 times the x coordinate, which is 6, should equal 9 if the point is on the graph. So recall that we're testing 6, negative 5 on 3y plus 2x equals 9. So notice that this is going to be negative 15 plus 12, and that is definitely not going to equal 9, because this is negative 3, and negative 3 does not equal 9. Therefore, we can say with certainty that the point is not on the line. For part B, they say find the gradient of line L. Now, to find the gradient, we need to rearrange the equation into the gradient intercept form, which is y equals mx plus b or plus c. So we have to rearrange it. Notice that it's 3y plus 2x is equal to 9. So that's the same as saying that 3y is equal to minus 2x plus 9. And then if we divide both sides by 3, we're going to get that y is equal to negative 2/3 x minus, no, actually plus 3. So this is the equation of the line that we just rearranged. And now we have the slope. The gradient or slope for line L is going to be minus 2/3. So for B, we just found that the gradient of line L is minus 2/3. So now we're going to focus on C. And then on C, for part 1, it says write down the gradient of a line perpendicular to line L. So if the gradient of line L is equal to minus 2/3, then a line perpendicular to that would have a gradient of, remember, opposite in sign and inverse multiplicative. So that would be 3/2. For part 2, it says find the equation of the line perpendicular to line L and passing through point P. So we said that if this was point P, it's off the graph, but you can have a line that goes through that point and is perpendicular to line L. And it goes through the point, as we said, 6, negative 5. So remember that we have everything here that we need because we have a point, which is 6, negative 5, and we have a gradient, which we called m2 to differentiate it from the first one, which is 3/2. So now all we have to do is plug the information into the gradient point equation. And remember that it is y minus y1 is equal to m times x minus x1. Of course, this can also be m2. It doesn't matter, right? So notice that the 6 is going to be x1, and the -5 is going to be y1. So we have that it's y minus -5, and here you have to be careful always when you have negatives for the coordinates. And this is going to equal 3/2 times x minus 6. So then all we have to do is rearrange everything, right? So first of all, let's take care of that negative sign there. So it's going to be y plus 5 is equal to 3/2 times x minus 6, which is the same as saying that y is equal to 3/2 times x minus 6, in this case minus 5, right? Because we're going to switch this to the other side of the equality. So then finally, we'll write the solution up here. Y is equal to 3/2 x minus, and this is going to be 9, 3 times 6 divided by 2, minus 5, which is going to give us finally that y is equal to 3/2 x minus 14. Very well, so next we're going to study systems of linear equations. So notice the word systems, right? So many problems involve sets of equations with several variables rather than just a single equation with one or two variables. Such set of equations is often called a set or a system of simultaneous equations because we find the values for the variables that solve all of the equations simultaneously. In this section, we are only going to consider sets of simultaneous equations containing two linear equations with two variables. We will take a brief look at 4 solution methods: the graphical method with technology, substitution method, elimination method, and then another method with technology but without graphing. So first we're going to talk about the graphical method. So the graph of each equation in a system of two linear equations in two unknowns is a line. The graphical interpretation of such a system of equations corresponds to determining what point or points lie on both lines. Two lines in a coordinate plane can relate to one another in one of 3 ways. So there's only 3 possibilities. Number 1, they intersect at exactly one point. You can see that here in the first graph where they intersect at one point. When that happens, you find exactly one solution for the system of equations, which is obviously going to be this coordinate. Let's call it x comma y. So when you find x comma y, the coordinate where they intercept, that would be the solution. Number 2, intercepts at all points on the line, i.e. the lines are identical or coincident. So in this case, you have 2 lines, but because they are the same, they coincide and they overlap. So this means that there are infinite solutions. And then finally, when they do not intersect, and that occurs when the lines are parallels. Remember that 2 lines that are parallel on a plane will never intercept. That's this case here where you have 2 lines that have the same gradient and therefore never intercept. This would have no solution. So in example 2.6, they ask us to use graphical features of a GDC to solve each system of linear equations. So for A, we have 2x plus 3y is equal to 6, and 2x minus y is equal to -10. Since we're going to use the GDC, what we have to do is rearrange this and write it as an equation of y in terms of x. So what do I mean by that? Well, if I have 2x plus 3y is equal to 6, I can rewrite that as 3y is equal to minus 2x plus 6, and then y is equal to -2/3 x plus 2. So this is what I'm going to graph for the first equation. I'll show you why in a second when we do this on the GDC. For this other equation, we can rearrange it and say that minus y is equal to minus 2x minus 10. But notice that I can divide both sides by -1 just to get rid of this negative here. So this is going to give me y is equal to 2x plus 10. So now that I have my two equations in the slope or gradient intercept form, I can proceed to graph them. So recall that the equations we found rearranged were -2/3 x plus 2 and 2x plus 10. So those are the ones that we have to type into the calculator. To do that, you have to go to the button that says y equals, which is right here on the top left corner of the calculator, y equals. And that takes you to this, where you can plug in the function, and then we can graph. So notice that we had to rearrange it in terms of y equals x something. So an equation for y in terms of x. So we write -2/3, so that'll be 2 divided by 3, x, which we can find here. So that would be -2/3 x plus 2. So that's the first line, it's graphed. And now we hit enter to go to the next line. And we're going to write the second equation, which is 2x plus 10. Okay, and once we plug in the equations, we can hit the button here to the top right, which is graph. And there they are. So those are the two lines. One is in red and the other one is in blue. The one in red is 2x plus 10, and the one in blue is -2/3 x plus 2. So all we have to do is find the point where they intercept. So for that, we have to go to second key, and then calc, which is above the trace key. And you're going to get option number 5 that says intersect. So hit that. And it's going to say which one is the first curve. So move your cursor a little bit, and we're going to say that the first curve is the blue one. So let's hit enter. That's the first curve. And the second curve is the red one. It doesn't matter where the cursor is. It just matters that you point out which one is the first curve and which one is the second curve. So hit enter, and then it says guess, hit enter again, and the calculator is going to find the intersection. So notice that the intersection occurs at x equals -3 and at y equals 4. So that means that the solution is going to be -3, 4. And we can test if this actually works, because -3 is your x value and it should give you a y value of 4. So let's test it to see if this is the actual solution. So for the first equation, y is equal to -2/3 times x, which is -3, plus 2. So if this is correct, we should get 4. And notice that this and this cancel out, but this is negative and so is this. So we're going to get 2 plus 2, and that equals 4. So it works for the first equation. Let's see if it solves the second equation. So y is equal to 2 times x, which is -3, plus 10, and this should equal 4. And indeed it does, because this is -6 plus 10, and this definitely equals 4. Therefore, that is the correct solution for the system of equations. And notice that it's only 1 point, because there's only 1 point that is on both graphs simultaneously. So for B, we have 7x minus 5y is equal to 20, and 3x plus y is equal to 2. So again, here we will have to rearrange these equations. So this first one would be the same as saying -5y is equal to -7x plus 20. And therefore, y is equal to 7/5 x minus 4, right? I'm dividing both sides by -5. So that's the first equation. The second one, let's rearrange it, and we're going to get that y is equal to -3x plus 2. So these are the equations that we'll need to plug into the graphing display calculator. Okay, so here we are with the GDC again, and we're going to plug in the equation. So remember that you go to y equals, and that takes you to the window where you can plug in the equations. We said the equations are y is equal to 7/5 x minus 4, And the other one we found was y equals negative 3x plus 2. So we proceed in the same way that we did before. So we're going to write 7/5, and that's going to be 7 divided by 5, right? So just go to the calculator and type in 7 divided by 5, x, which is right there, minus 4. So this, we can use this minus because we're subtracting 4, minus 4. Hit enter, go to the next line, and we type in negative, so use this for negative, negative 3x plus 2. And now we are going to graph. So let's hit the graph button, and there they are. So here's the intercept. So this does have a solution. Remember, to find the intercept of two lines or two graphs in general, we go to second, and on the trace button it says calc, and there it is, number 5, intersect. So there they are. First curve, the blue one, yes, hit enter. Second curve, the red one, yes, hit enter. Guess, yes, and there it is. That's the solution right there. It's going to be, and it's all in decimals, right? It's going to be 1.363 to 4 significant figures, comma, negative 2.09, and we have 3 and one more 1. So this would be the solution to this system of equations. Now this is the same as saying 15 over 11, comma, negative 23 over 11. Okay, so we're going to do example 2.7 that says use the elimination method to solve the system of linear equations. So here's the system, which is 5x plus 3y is equal to 9, and 2x minus 4y is equal to 14. So elimination, as the name suggests, is a method by which you eliminate one of the variables and therefore solve for the other variable, and then use that solution to come back and solve for the first variable. Okay, so what does that mean? That means that we have to eliminate either x or y. Now in this case, I think it's easier to eliminate y. We would eliminate them by adding the two equations. But if we add the two equations as they are now, we're not going to eliminate anything, right? We're just going to get 7x, if we added them, 7x minus y is equal to 23. And then this would still leave us with two variables. But the idea is to eliminate one of the variables. So we want to eliminate y. So how do we do that? Well, in order to do that, we need to have the same number, but opposite in sign. So what we need to do is to make these numbers the same, right? If we're going to eliminate y, we need to make them the same, but opposite in sign. So how do we do that? Well, if we multiply the top equation by 4 and the bottom equation by 3, we are going to be able to get what we want. So if you multiply an equation, you have to multiply every single term in it and both sides of the equality, right? So 4 times 5 is 20, so 20x plus 12y is equal to 9 times 4, which is 36. Then multiply by 3. 3 times 2 is 6. So 6x minus 12y is equal to 3 times 14, which is 42. So now we have the situation we wanted. Now we can add these two equations. If we add them, we're going to get 26x, but then y will eliminate, right? Because 12 minus 12, or 12 plus negative 12, is 0. And then we have to add this part. So we're going to get that 26x is equal to the sum of 36 and 42, which is 78. And then we can divide both sides by 26, and we're going to get that x is equal to 3. So we have solved for x by eliminating y, but we still have to solve for y. So how can we do that? Well, just grab one of the original equations, doesn't matter which one. I'll take this one and substitute x for 3. So 5x becomes 5 times 3 plus 3y is equal to 9. And then we have that 15 plus 3y is equal to 9. So 3y is 9 minus 15. So that implies that 3y is equal to -6, and therefore y is equal to -2. So that means that we have a solution. So the solution will be 3, -2, which would also be the point where they intercept, as we saw graphically. So here we are in example 2.8, and it says use the substitution method to solve the system of linear equations. So the substitution method, as the name implies, requires a substitution. So for that, what we have to do is rearrange one of these equations. I'm going to rearrange the first one. So if I rearrange this, notice that I can rewrite this as -y is equal to -3x minus 9. And then dividing both sides by -1, I get that y is equal to 3x plus 9. So this equation we're going to use to substitute into the second equation. So if whether you rearrange for the first one or the second one, what you get, you have to plug in the alternate equation, right? So this is a solution for y. Notice that y is equal to 3x plus 9. So I'm going to substitute y here for 3x plus 9. So I'm going to get that 6x plus 2 times y, but that's now 3x plus 9 is equal to 2. So notice that now I have an equation with only one variable, which is easy to solve. So I'm going to get 6x plus, and I have to do distributive property here, so plus 6x plus 18 is equal to 2. I'm going to get that 12x plus 18 is equal to 2. And then I will get that 12x is equal to 2 minus 18. Therefore, 12x is equal to minus 16, and then x is equal to minus 16 over 12. And then we can simplify this because they're both divisible by 4. So we're going to get that x is equal to minus 4/3. So once we solve for x, we can use this value to solve for y. Then all we have to do is plug it in here where it's easier. You see that? So y is equal to 3 times x, but we already found that x is minus 4/3. So that plus 9 should give us the solution for y. So y is then equal to, notice that this cancels out, minus 4 plus 9. And finally, we get that y is equal to 5. So we found the solution. The solution will be a coordinate where these lines intercept, and that is going to be -4/3, 5. So this is example 2.9, which will be the last one on this video. And it says, when flying in still air, i.e. no headwind or tailwind, with its propellers rotating at a particular rate, a small airplane has a speed of s kilometers per hour. With the propeller rotating at the same rate, the aeroplane flies 473 kilometers in 2 hours as it flies against a headwind, and 887 kilometers in 3 hours flying with the same wind, but this time as a tailwind. Find S and find the speed of the wind. Okay, so don't be impressed with this type of word problem because it sounds complicated. But what you have to do here is really organize all the information that you have, and you have to understand what they're talking about. So if you have an aeroplane, and I'm going to try to draw an airplane here. So let's say this is the tail, and excuse my drawing abilities, they're not exactly superb. So that would be the tail, and let's say that these are the wings. Whoa, didn't turn out so bad. And then a headwind is a wind that blows against an object, right? So you can hear about headwinds with aeroplanes or boats. So this would be a headwind, and a tailwind is a wind that actually speeds up the aeroplane. So it says that when the propeller is, well, the propeller is always rotating at the same rate. And it says that the airplane flies 473 kilometers in 2 hours when it is flying against the headwind. So that would be this case here. So this is case 1. Case 2 is that it flies 887 kilometers in 3 hours when the wind is a tailwind. Okay, so obviously we're seeing systems of equations, so we have to somehow solve for S, which is the speed of the airplane, and they also want us to find the speed of the wind, which we're going to call W. So how do we do this? Well, we have to relate all the information, and notice that they're talking about distance and speed, right? From physics, we know that distance is equal to speed times time. And because we have to solve for speed, this is a very convenient way to put the information. So speed times time. Okay, so the first equation, we have 473 kilometers, which is the distance, is equal to the speed, which we don't know. We don't know the speed, but we know that it's speed times time. Notice that we can also write this as time times speed is equal to distance. So we know that the time is 2 hours, so let's just write 2. And then now we have to times this by the speed. So what would be the speed? Well, we know that the airplane is flying in this direction with a speed s, but the wind is blowing in the opposite direction with a speed w. So that means that we're going to get a total speed of s minus w. So this would give us the distance of 473 kilometers. Likewise, for 887 kilometers, we have 3 hours, and we have the speed of the airplane, but this time the wind is a tailwind, so it's going to favor the speed of the airplane. It's going to make it go faster. So let's rearrange this a little bit. Let's do that over here. So this is going to be that 473 is equal to 2s minus 2w, and that 887 is equal to 3s plus 3w. So notice that now we have a system of equations with 2 unknowns and 2 equations. So because this is part of the technology section in the book, I'm going to show you how to use the GDC to solve these simultaneous equations without graphing. So here we are again on the GDC, and I'm going to show you how to use technology to solve simultaneous equations without graphing. So for this, you have to go to a button here that says Apps, which is, let's say, second from left to right in the third row. It says Apps. So you're going to hit that, and you're going to get a list of different applications that the calculator has. And we want to use number 9, which says polynomial simultaneous to. So hit number 9, and we have a main menu with several options. Number 1 is a polynomial root finder, which we will find very useful in the future. But now we're going to focus on number 2, which is the simultaneous equation solver. So click on number 2, and then it says how many equations? It's 2 equations. How many unknowns? We have 2 unknowns, which are s and w. And we will now have to click on the graph button, which is under the next. So this is the screen. That means that the next symbol would be right above the graph button. So hit on that, and it gives us this. So notice that it's in terms of x and y, but that doesn't matter. Recall that we said that the equations that we got before were 473 is equal to 2s minus 2w, and the other one was 887 is equal to 3s plus 3w. So these are the 2 equations that we're going to solve with the calculator. So s can be our x and y can be our w, or w can be our y, I should say. So let's plug everything in. So we have x, the first x will then be 2 So all we have to do is type 2, and then enter. And that gives us that. Now it says minus, so we have to subtract and then hit enter and 2 for y, which is w, right? And this equals the solution, which is 4, 7, 3. We hit enter there, and it takes us to the next equation. And for the next one, we have 3s, or 3x. Hit enter, plus 3w. So we type in 3, hit enter, and then the solution, 8, 8, 7. Hit enter, and then notice that solve is going to be above the graph button. So we hit on graph, and there it is. We get the two solutions. So notice that this is actually the solution. This is not for x because we're talking about s. So this is the speed of the airplane. And then this is going to be w. Now, this is approximately, more or less, 266 kilometers per hour. And the speed of the wind would be approximately 29.6 kilometers per hour. Now notice that this notation, or this answer, is in 3 significant figures.